Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video where I have two bonus problems that are similar to this one which you guys can try to solve. Alright, so I have 5 to the power of k is equal to 0. So, for a solution, we start with 5 to the power of k is equal to 0. Then I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of k is equal to 0. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would be equal to b times log a. And what is actually so useful about this property is, let's say we have 7 to the power of x is equal to 9, right? Well, if we use this property, before using this property, first off, x, as you see, this is an exponent. And we can't really do much when x is an exponent because it's really hard to solve for x, in this case especially, because this x is going to be a decimal. So by using this property, we first have to take the log on both sides. And then we can use this property by moving x to the front. So we have x times log 7 is equal to log 9. And now, because x is an actual term, it's pretty simple to solve for it. All we have to do is divide by log 7 on both sides. And we get x is equal to log 9 over log 7. So as you can see, this property is really useful for solving for x when it's an exponent. So going back to our normal problem here, we had log 5 to the power of k is equal to log 0. Now we can move this exponent k to the front of the logarithm. So now I have k times log 5 is equal to log 0. Now, we're obviously solving for a k, so I'm going to go ahead and divide both sides by log 5. So then these two will cancel out. And I'll be left with k is equal to log 0 over log 5. Now, log 0, this is actually undefined. And log 5, this is equal to 0.6990. So k is equal to undefined over 0.6990. And if you can't really divide undefined by anything because it's simply undefined. So this means that k is just undefined. It has no value. You can't take the log of 0. And also, you can't take the power of any number and make it 0, because 0 is not possible. You can get 1, because if you took 5 to the power of 0, that would equal 1, but 0 isn't possible. You can't take the power of a number and get 0. By 5 to the power of x is equal to 50. Now 50, this is the same thing as 5 times 10. So now I have 5 to the power of x is equal to 5 times 10. Now I'm going to go ahead and divide both sides by 5. So then these two cancel out. And I'll have 5 to the power of x over 5 is equal to 10. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So for 5 to the power of x over 5, well 5, this is the same thing as 5 to the power of 1. So 5 to the power of x over 5 to the power of 1, that's going to equal 5 to the power of x minus 1, which is equal to 10. Now I'm going to go ahead and take the log on both sides. So now I have log 5 to the power of x minus 1 is equal to log 10. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. And this property is actually really useful because, as you see here in the form log a to the power of b, b is an exponent. And solving for an exponent is actually really hard. For example, if I had 7 to the power of x is equal to 9, x is an exponent, and x is actually a decimal because you can't take 7 to the power of a whole number and make it 9. So this is actually going to be almost impossible to solve by just on your own. But however, when we use this property, we can take the log on both sides. So we have log 7 to the power of x is equal to log 9. And now I can go ahead and move this to the front. So this would equal x times log 7 is equal to log 9. And now I can divide both sides by log 7 because, as you can see, x is an actual term now, and it's pretty simple to solve for it. So now we have x is equal to log 9 over log 7. So now going back to our original problem, we had log 5 to the power of x minus 1 is equal to log 10. So now I can go ahead and move this exponent x minus 1 to the front. So now I have x minus 1 times log 5 is equal to log 10. Now I'm going to go ahead and divide both sides by log 5. So then these two cancel out. And I'll be left with x minus 1 is equal to log 10 over log 5. So now I'm going to go ahead and add 1 on both sides. So I have x is equal to log 10 over log 5 plus 1. Now log 10, this is the same thing as 1. So now I have x is equal to 1 over log 5 plus 1. Now log 5, this is equal to 0.6990. So now I have x is equal to 1 over 0.6990 plus 1. Now 1 over 0.6990 is 1.4306 plus 1. This is equal to 2.4306. So that is our answer. All right, so I have x to the power of 2 is equal to 3 to the power of x. Now the first thing I'm going to do is I'm going to take the natural log, or ln, on both sides. So now I have ln x squared is equal to ln 3 to the power of x. And now an important property of logarithms is that if I take the natural log, or even normal log, of something in the form a to the power of b, I can actually move my exponent b here to the front of the logarithm. So this is going to equal b times ln a, or b times log a. So in this case, we're using ln, so now we can move our exponent here to the front, for both of them actually. So now I'm going to have 2 times ln x is equal to x times ln 3. Now I'm going to divide by 2x on both sides. So now from my right hand side, these two x's will cancel out. From my left hand side, these two 2's will cancel out. So I'd be left with ln x over x is equal to ln 3 over 2. Now, if I take e to the power of ln a, this is the same thing as simply a, because the e here and the ln, they simply cancel out. Same with e to the power of ln x. This is the same thing as x, because the e and ln cancel out. So x here, I'm going to replace with e to the power of ln x. So now I have ln x over e to the power of ln x is equal to ln 3 over 2. Now, e to the power of ln x over e to the power of ln x, that's the same thing as ln x times 1 over e to the power of ln x. And now 1 over e to the power of ln x, that's the same thing as e to the power of negative ln x. Now, an important function for logarithms is known as the W-Lambert function. And taking the W-Lambert function of something in the form a times e to the power of a, this will give you simply a. So in this case, as you can see, a, we have ln x and we have negative ln x. And to use this property, these two need to be the same. So what I'm going to do is I'm going to multiply both sides by negative 1. So now I have negative ln x times e to the power of negative ln x is equal to negative ln 3 over 2. And now, as you can see, both a's are the same. And now we can go ahead and take the W-Lambert function on both sides. So now I have w of negative ln x times e to the power of negative ln x is equal to w of negative ln 3 over 2. Now, this is simply equal to a, which is negative ln x in this case. So now I have negative ln x is equal to w of negative ln 3 over 2. Now, remember the property. Say that if I have something in the form ln a to the power of b, this is equal to b times ln a. So now I'm actually going to reverse this property, and in this case I have negative 1 times ln x, and I'm going to move this negative 1 to the front again. So now I have ln x to the power of negative 1 is equal to w of negative ln 3 over 2. Now I'm going to go ahead and take e to the power of both sides. So now I have e to the power of ln x to the power of negative 1 is equal to e to the power of w of negative ln 3 over 2. And now, remember how e and ln cancel out, so I'll simply be left with x to the power of negative 1 is equal to e to the power of w of negative ln 3 over 2. Now x to the power of negative 1, this is the same thing as 1 over x. So I have 1 over x is equal to e to the power of w of negative ln 3 over 2. And now these two can simply switch. So now I have x is equal to 1 over e to the power of w of negative ln 3 over 2. So this is our answer.